Have you ever found yourself lost in a moment of quiet reflection, pondering the roads not taken? That split-second decision to turn left instead of right, the job offer you accepted or the one you turned down, the person you spoke to, and the one you let walk away. We all have these moments, these pivotal forks in the road, where our lives branch into a new direction. We tell ourselves it's just a daydream, a fleeting what if. But what if it's more than that? What if that feeling, that deep intuitive sense that another version of your life is playing out, isn't just a product of your imagination? Imagine for a moment that other you, the one who took that different path. Are they looking up at the same sky right now from a different city, a different country, perhaps even a different world? Did they pursue that passion you set aside? Are they happier? Have they made mistakes you managed to avoid, or found successes you only dream of? This isn't merely a philosophical exercise, it's a question that pushes at the very boundaries of our perceived reality. The idea that every choice you've ever made, and every choice you ever have made, has spawned a new, tangible universe. For centuries, this was the realm of fiction and fantasy. But today, some of the most brilliant minds in physics and cosmology are suggesting that this staggering concept might be true. They propose that our universe, with its billions of galaxies and trillions of stars, might not be the whole story. It could be just one bubble in a vast cosmic ocean of other universes, a single page in an infinite library of realities. This is the multiverse hypothesis, and it emerges not from wishful thinking but from the strange and counterintuitive predictions of our most successful scientific theories. From the mind-bending implications of quantum mechanics, which suggest that every quantum event splits our world into multiple branches, to the cosmic inflation theory, which posits that our Big Bang was just one of many, creating an endless patchwork of universes. These aren't just wild guesses. They are logical, albeit mind-boggling, extensions of mathematics that accurately describe the world we see. Today we'll journey to the cutting edge of science to explore these bold theories. We will investigate what these parallel universes might look like. Could some be nearly identical to ours, differing only in one tiny detail? Could others have entirely different laws of physics where the very fabric of reality is alien to us? We'll examine why leading physicists, people who have dedicated their lives to understanding the cosmos, take these ideas so seriously. And we'll confront the ultimate question: could we ever find proof? Could we ever hope to detect or even communicate with another universe? Prepare to have your understanding of existence challenged. This journey will take us from the infinitesimally small world of quantum particles to the incomprehensible scale of cosmic infinity. It's a story of possibility, of reality, and of our true place in the cosmos. So buckle up and open your mind. Welcome to the multiverse. Multiverse is an umbrella term for ideas that propose more than one universe. Some theories imagine countless entire universes with different physical laws. Others imagine endless branches of reality created every time a quantum choice is made. The word covers very different concepts, and each has different implications. Among the many attempts to grasp the strange reality of quantum mechanics, one interpretation stands out for its sheer audacity. This is the many worlds interpretation. First proposed in the 1950s by physicist Hugh Everett III, it offered a radical solution to the measurement problem. At the time, the Copenhagen interpretation said a quantum system exists in a superposition of all states, until an observation collapses them into one reality. Everett found this special role for the observer arbitrary. He asked, what if there is no collapse? His answer was that the universe itself splits. The many worlds interpretation posits that every time a quantum event with multiple outcomes occurs, reality branches. A separate, parallel universe is created for each possibility to play out. The universe isn't a single timeline, but a constantly branching tree of realities, with every quantum event creating new limbs. This applies to everything, including you. That choice you made between coffee or tea this morning, the universe split. In the reality you now perceive, you're drinking coffee. But in another, equally real universe, a version of you is sipping tea, completely unaware of your existence. Every quantum-level event, underpinning every decision, spawns a new world where an alternate history unfolds. The elegance of many worlds is that it removes the need for wave function collapse. It takes the core equation of quantum mechanics and applies it universally. The observer is no longer special. You simply become entangled with what you measure. Your reality branches along with the particle's state. In one branch you measure spin up, in another, spin down. Both outcomes happen. You just happen to be in the branch that experienced one of them. This elegance, however, implies a reality of unimaginable scale. A staggering number of parallel worlds are created every fraction of a second. These worlds aren't in another dimension, they coexist with us, but a process called quantum decoherence prevents them from ever interacting. We can never visit these other branches, but the theory suggests they are just as real as our own, an infinite cosmic tree where every possibility is made real, somewhere. Modern cosmology suggests a different multiverse, eternal inflation. Our universe could be one bubble in a frothing multiverse. Each bubble might have different physical constants. In some, atoms as we know them never form. In others, stars burn brighter or not at all. Some thinkers, like Max Tegmark, propose that any mathematically possible universe exists. If a complete mathematical structure is self-consistent, it may correspond to a physical reality. This idea is radical. It says existence equals mathematical possibility. These multiverse ideas are not the same. Many worlds branches from quantum measurement. Bubble universes come from cosmic inflation. The math and the evidence for each differ, and the ways we might detect them are very different. Detection is the big challenge. For bubble collisions, cosmologists search the cosmic microwave background for subtle patterns, faint scars of collisions long ago. For quantum branches, detection is trickier. Many worlds predicts no direct signal because branches don't interact. Still, quantum experiments and entanglement research push our understanding of what's possible. If multiple universes exist, it reshapes our view of chance, fate, and explanation. Some puzzles, like the finely tuned constants of physics, could be explained by selection effects. We find ourselves in a universe that allows life. But multiverse ideas also raise hard questions about testability, meaning, and scientific method. What about interaction? Could you ever meet your alternate self or change your past? Most multiverse models forbid causal interaction, so classic time travel paradoxes aren't solved by multiverses. Instead, the multiverse reframes what if as physical branching, not as a route to rewrite history. Serious researchers work on ways to test aspects of these theories. Particle physics, cosmology, and quantum foundations overlap here. Importantly, mainstream science regards some multiverse ideas as speculative, but they are motivated by mathematical results and by otherwise unexplained phenomena in cosmology and quantum theory. We've journeyed to the edge of physics, exploring a concept that challenges the definition of everything. From the sea of bubble universes to the branching timelines of quantum mechanics, the multiverse is a tapestry of possibilities. But whether it's true or not, asking the question stretches the very fabric of science and philosophy. It pushes science to its limits, forcing us to confront the principle of falsifiability. If we can never observe these other worlds, is it still science or has it become metaphysics? This is the central controversy. Philosophically, it forces a reckoning with identity. If countless versions of you exist, each living out every possible choice, what does it mean to be you? Are you unique or just one data point in an infinite set? The implications change how we think about explanation, probability, and the scope of reality. Take the fine-tuning of our universe's physical laws, which seem perfectly set for life. Why this luck? The multiverse suggests it isn't luck but statistics. In a cosmic lottery with infinite universes, some are bound to have the winning numbers for life to emerge. We simply find ourselves in one such universe because we couldn't exist anywhere else. This also redefines probability. In an infinite reality, anything that can happen, will happen. Every alternate choice, every different path is playing out somewhere. This realization is a profound shift in perspective, as significant as Copernicus removing Earth from the center of the cosmos. Our entire vast universe might just be one bubble in an endless cosmic foam. For these reasons, the multiverse remains one of the most exciting and controversial frontiers in modern thought. It's exciting because it represents the ultimate quest for understanding, pushing our theories to their limits and inspiring cosmic awe. It's controversial because it resides in the gray area between mathematical prediction and physical proof. Brilliant minds fall on both sides. Some see it as an unavoidable consequence of theories like string theory and inflation. Others dismiss it as untestable speculation. This intellectual tension defines the frontier. Yet the hunt for indirect evidence is on. Scientists are searching for cosmic bruises in the cosmic microwave background. anomalous patterns that could signify a long-ago collision between our universe and another. Such a discovery would be the first tangible sign that our reality is part of a much grander multiversal structure, so we are left standing at the precipice, gazing into an abyss of possibility. The multiverse suggests our reality is infinitely larger and stranger than we ever imagined. If you loved this deep dive, our journey doesn't end here. Subscribe for more explorations into the fundamental nature of reality. And now we want to hear from you. Does the thought of infinite versions of yourself bring comfort or concern? Is the multiverse a scientific necessity or a philosophical indulgence? Tell us in the comments. Let us know which multiverse idea you find most compelling, the quantum many worlds or the inflationary bubble cosmology. Want a separate deep dive into any of these? Your curiosity fuels our next voyage into the unknown.